So welcome all for this new chapter of SQL. It's chapter 4, which we are going to continue for our proc SQL or SQL essentials topics in SAS. So here majorly we are going to cover the part which is called as SQL joins. So there are four topics here: introduction to SQL joins, inner joins, outer joins, complex SQL joins. So when we say joins is nothing but the concept where we are going to connect two tables at a time in a query. So most of the time SQL joins could represent like your data step merge or your data step multiple set statement. So how it works here, we are going to look into in more detail, and we'll also understand the natural way of joining the tables without any specific requirements. Okay, so let's get introduced with the joins with SQL. So objectives here is we'll identify different ways to combine data horizontally from multiple tables. So when I say horizontally, it's like joining the tables sideways on the basis of common column. So this is very much similar like your data step merge. Okay, and we'll distinguish between inner and outer joins, and we'll understand the natural way of joins of SQL, which is called as a Cartesian product. So let's understand the same join concept through a scenario. Management has requested multiple reports. You have to understand how to combine the data from the tables to complete these reports. So when you are telling you need to join, you need to have minimum two tables to perform these operations. So now, up till now, we learned about SQL steps where we were writing in your from clause only one table, which is your input source to query your query which you have written. Correct? But now you have two source of tables. How those tables we need to connect, what is the information we need to take in, that's all we are going to learn here. And hence this is the scenario. It's a very simple scenario. It's telling management has requested multiple reports, out of which it's telling you have to understand how to combine the data from tables to complete this request. Now there are two tables, customer and transaction. You need to just compare this or join these two tables or connect to this table, or you need to merge these two tables so that you get a appropriate report. Okay, so this is what is expected. So when we say transaction and when we say customer, of course there should be one common column. So according to you, what do you think at this point would be a common column? Understand we have a customer and you have a transaction table.
Customer ID.
Absolutely. Because when we have a table for customers, the customer ID is going to represent the information for customer in detail about its ID. Then we have columns in this table like name, maybe last name, maybe we have their birth dates, maybe we have their date on which they have performed a purchase with the organization or something else. But here they are showing you only two columns. And of course, transactions is a table where you have the information about which customer has performed the transaction, like what is the action and the amount what has been performed the transaction. So if you see ID is there, here also you have an ID. So you have a common column called as ID. So customers table is representative of a customer dimension table. There would be additional columns with data about our customers, including address, age, and so on. But at this point, we are only focusing on these two columns. Whereas transaction is again, as we discussed, is a repetitive of a fact table. There would be columns holding all the key column data like product ID. There would be employee ID also, and so on. But here we are just concentrating on these columns. Okay, so this is the two table and we have explored it. So we find customer ID is common in the both the tables. So when you're combining data from multiple tables in SQL, it will always perform a sideways or horizontal join. So that means this table will combine with this table horizontally. Row it were combined on the basis of row. Remember your merge technique? It was horizontal way of combining the table. Okay, so that's what it's telling. SQL uses joins to combine tables horizontally. Requesting a join involves matching data from one row in one table corresponding to a row in your second table. Natural ways, if you just write these two table names in your proc SQL statement, it will simply perform horizontal join. But if you specify what type of join you need to perform, then it will involve matching data from one row in one table, where it will try to look for the same common row or common values on a common table or a common column to combine it on that particular observation to create a single row as an output. That's what they are trying to tell. So matching is typically performed on one or more columns in the two tables which are in common. Okay. So before moving, answer this poll. Which of this data step statements is used to combine tables horizontally?
Merge.
Merge.
Yes, we have learned about merge. Absolutely. So these are the types of joins. ProcSQL supports two types of joins, inner join and outer join. Outer join has three ways of joining. So what is inner join? Now, if you look into this diagram, it's showing you two circles are been combined and they have highlighted a common area. So this is where we are joining two tables on the basis where you are selecting only matching rows is termed as inner join. Whereas outer join, there are three ways of performing outer join: left, full, right. So if you look into this diagram, left join means you are going to not only select the matching rows but also the non-matching rows from the first table. Here the table is aligned to the left side of this diagram, so hence it's called as a left join. Okay, here you are selecting both non-matches from both the tables and matches from both the tables, hence it's a full join. Whereas this is a right where you select matches and non-matches from the second table or the right side of table, hence it's called as a right join. So we'll see each join in detail, what is the syntax and how it works along with inner join and types of outer joins. So before that, let's understand what is a Cartesian product. So moving with this Cartesian product, I would like to show you the same. Please hold. I'll start my studio. I hope you people have kept your PDF book handy and you're connected to your SAS studio.
Yes, sir.
Great. See to it that you have also connected to your data sets via lib name statement. Okay, so I have opened a code which is D00A for SQL fourth chapter, which is actually a SQL statement where you are creating new tables. Okay, so I'm creating a table customer and I'm creating table transaction. So this table we don't have physically available in your database. So I'm creating this. So it's same like your data step data lines which we have used to create data sets. So this two data sets it's created. If you look into your log, so this is what it was telling, that 3 rows for work.customer created, whereas 3 rows for transaction created. Now if you observe these two tables carefully, we have two table with us, customers, which has ID and name, whereas transaction is a table which has ID, action, and amount. So if I move into my coding where I'm going to simply join this table, we know that ID is common. So let's keep on writing an SQL statement, writing select. Okay. So I may select all the columns. I simply write from, it's my data set saved currently into work library. So even if I do not provide a libref for my data table is all fine, it will still take it from work library. So I simply write customers, correct, comma I give, because it's an SQL program language. You need to specify the column names, the table names separated by comma, and we use transactions. Okay, so these are the two tables which we have created by executing. So customer transactions. So let me check the spell. Fine, so I've used this from clause. I'm not adding any other clauses of my SQL here, and I simply quit. Now understand the tables which we had created. Here we have 3 rows with 2 columns, ID and name. Here also we have 3 rows with 3 columns, ID, action, and amount. Now I'm simply writing an SQL query, okay, with selecting all the columns from these two tables. Let's see the output. Okay, so we do not have row number. Let's have number, execute. Now how many rows we have in each table? 3 rows, correct? How many rows you see in your output now?
6.
9.
9.
Yeah,
Swarupa.
yeah, sorry.
Yeah, ideally you wanted to say it should be 6, but here it's showing us 9. Okay. Now understand. ID 001 Smith. See what is happening. ID 02 purchase. Before that, where are your tables? Observe your tables carefully. This is customer table. You have ID Smith 104 Jones 102 blanks. Okay. Transactions 102 purchase, 103 return, 105 return. How is the result? What is happening?
Customer
Every,
row is
every,
linking to another table.
yeah, every
Mhm.
variable is
Yeah.
cross-functioned with
Linking to another table.
yeah.
Transaction.
Correct. So what is happening is, if you observe this 1001 Smith, 1001 Smith, these are 3 rows. Then 104 Jones, 3 rows, 102, 3 rows. This is from customer. Okay. Then we have ID. So if you see transaction 102, 103, 105, and if you see the result 102, 103, 105 with this again 3 rows from the second table, 3 rows from the second table.
So
So what has happened?
all possible combinations.
No, it's not a possible combination. So what has happened here is, by default, every row from the first table, that is customer, is combining to each and every row for the second table. See? same row is combining to 3 rows for the second table. Then the second row from the first table is combining to the 3 rows of your second table. Same goes here. Are you getting it what has happened?
But Ashwini, how come the IDs are like
I'll
two
tell you, I will
IDs?
come to that. Just understand the rows. What has happened? Is this clear?
Yes.
Yes.
Yes. Shanmuga, Swarupa, Padma, Monica. So
Yes.
every row from the first table is combining with the every row from the second table. Okay. So what has happened? 3 rows from first table combining to every 3 rows to the second table. So 3 into 3,
9.
9.
that is why you're getting 9 rows. And this type of output is termed as Cartesian product, which is a default natural behavior of proc SQL in SAS. That whenever you write two tables in from class, simply it will perform a Cartesian product where, of course, because we have written an asterisk sign, understand Priyanka, the result which we are saying is it's selecting all the columns from both the tables. Got it now? Priyanka,
Yes,
that is why you see this.
but
Okay,
IDs are different. No.
values are different, but here it is just taking all the columns and it's combining every row from first table. It's combining with the every row with the second table. So this is the result, which is the default behavior of proc SQL, which is termed as Cartesian product. So if you see a log, here also it's telling the execution of this query involves performing one or more Cartesian product joins that cannot be optimized. So this is where it's trying to tell you that this is not the exact, maybe the report which you are looking for. So this is simply whenever you write two tables in your from clause without any joining criteria, it performs a Cartesian product. In case now you want to select the columns as per your requirement, that you simply want ID from any one table to be selected, you want name, action and amount. So you need to specify to SAS telling that you are going to select maybe ID column, but again, ID from which table? That is more important, correct? So I simply write ID, name, comma, you have action column, comma, and you have amount column. Okay, so let's execute and check. So it has a error. So what error? Because of ID column. So it's telling ambiguous reference column ID is in more than one table. Yes, we know in both the tables, the column name ID is same. So when you are selecting the ID column for querying, of course, it will not understand from which table we are selecting this column. So if you want to select only from customer table, so you can write here your table reference. So it's customer dot ID. All right. Now I execute this. So it will select this ID column only from the customer table. And of course, rest thing is the same. See, 9 rows, it's a Cartesian product. So if you check the note, you have the same information. So the first part of our result is solved about the columns, but how about the rows? Now we know ID is common in both the tables. So we want to select only those rows where ID is common. So I can always write telling where I can say as customers.id column is similar with second column, which is transactions.id. So now when I execute this, my where here is acting as if a joining criteria, and yes, it's finding there is only one row in common with ID value, which is 102 is common in both the tables, hence you get only the matching row. So if you check your customers, you have 102. When you check the transactions, you have 102. So only this is a common row, hence you get only the common rows, which is a inner type of join. So this is a very simple program which we have come across, that where is working as a joining criteria, where we are telling SAS that the ID column from customer table is same with the ID column of your transaction table. Hence, the result comes as a inner join, which is only matching rows. All fine? Is this understood?
Yes.
Yes.
Yes. So every time, is it feasible for us to write your table name? In case now here it is a very small table with its name saved in your work library, but what if in future you have a huge table saved in various libraries? So are you every time going to provide that here, that libref and a table name? So it's not feasible. So best part what we can do is, I can always give an alias name to this table in my from clause by using a keyword as. I write C, whereas transaction I write as T. Okay. So instead of writing the whole table reference, I give it as this way. Same goes here. And same you can represent in your select clause. So C.id, comma name, action, amount are the columns. Whereas here, customer and transaction, you are giving an alias name, C and T, and joining criteria, and where you are telling C.id is equal to D.id. So let's check if this is similar result what we see as earlier. Done. Same thing. Only referencing the columns from your table, and the table names you provide an alias name. That's it. All right. So this is actually the Cartesian product. That is what it's telling. A query that lists multiple tables in a from clause without a where clause procedures, or without it produces all possible combinations of rows from all tables. This result is termed as Cartesian product. So to understand how SQL joins or processes a join, it is helpful to understand this concept called as Cartesian product. So this is what has happened. When we wrote in your from clause only two tables, so every first row from the first table combines with all the rows from the second table. So first row is combining at first with the first row of transaction. Then again, the first row will combine with the second row of transaction. First row combines with the third row of transaction. That is why earlier we would see that every row from the first table is combining with the every three rows of your transaction. Same goes for your second row, which combines with all the three rows. Then it moves to the third row of customer, which combines with all the three rows of your transaction. Hence, it is every three combines with every three, 3 into 3. Hence, you get the product is called as Cartesian product. And of course, this is not a required result. Correct? So we know when it is a Cartesian product, both the rows are non-matches, but still it puts it accordingly, right? You get total 9 rows, 3 into 3. So this is how it gives you the Cartesian product depending on how many rows it is reading from each table. And of course, we get this note into log. So to avoid this, we can always subset the rows by telling SAS what are the common columns. So answer this poll. How many rows and columns are returned from this query? Now look at this query, it's asterisk sign in select, and these are the two tables.
20.
5 rows, 20.
Yeah,
20
12.
rows.
Yeah, 20 rows.
Agreed. 5 into 4. Shanmuga.
It's 20.
5 columns.
Correct. 5 columns from first table, 4 columns from the second table, 5 into 4, 20 rows. Done?
Yes.
And how about the columns?
There will be 5 combining both of them.
So it will select all the columns from both the tables,
Yes.
irrespective matching or
Match.
non-matching columns. Correct?
Yeah.
So ID name from the first table, ID action amount from the second table. Correct?
Yes.
That's it. So this is what is requested. So to achieve this, first and foremost, you simply write your query, and we use a where clause telling SAS ID from both the table is common, hence you get this output. Look at the syntax carefully. So when you use this from clause, you specify the table names. So in SQL, you have more than 2 tables to be written in this from clause, where you can always perform a join. So limitation is up to 256 tables, which you can write in this from clause. Here we are using 2 tables. Okay. If you see, the output is selecting all the columns. See, though we know ID is repeating in the result, correct? So in this criteria, we can always request how ID can be selected. So answer this poll. Why are there 2 ID columns in the result?
Because we selected all the columns from both the tables.
Yes. So because of your asterisk sign in your select clause or select statement, it used to select all columns from both the tables. Therefore, you have 2 IDs in the result. So when you specify columns with the same name from more than one table, it is necessary to qualify the column names. Hence, you give the alias or you give the column name, like telling custom table name dot column name in your select clause. So your table name which you are using it in your from clause. So moving ahead, if I open this activity, so before opening this activity, you should have customers and transactions data, correct? So it's activity A02. So before that, you need to create this table. So how will create these tables? In your folder of SQL, within the code with lesson 4, you need to open this D00A, which will give you the code where it's creating these 2 tables. First create this table and then move ahead with the activity. So open this. So do we have this activity currently here open? No. If it's not there, let's work out with this activity. It's the same thing, but it was telling you are selecting from Okay. At this point, did you open this where you are creating this data sets?
Yes, Ashwini.
Okay. Others?
Yes,
Yes,
Ashwini.
Yes.
Okay. So as per our current scenario, I'm just simply selecting all columns from both the tables. And in where clause, I'm simply writing ID equal to ID. Okay. So now when I execute this code, do you think it will work? So this is what it's telling. When I'm simply writing ID equal to ID in where clause, ambiguous reference column ID is in more than one table. So it's not understanding this ID is equal to the second ID. So both the tables have the column called ID. So it's not understanding ID equal to ID because both tables have same ID. Hence, it will not work when you tell ID is common in both the tables. So you are going to move ahead telling ID from customer table is similar with ID from transaction table. That's what this poll was. So you get an error. So what message is displayed in log when the program is executed about the column names? Absolutely. So this is where you get the errors. So to complete this code and to achieve this report, to display your ID column only once in the result, qualify the ID column in your select. So this way you can provide the table name dot column name. And here in where clause also, you can tell SAS that ID from customer is similar with transaction with customer. So this way you write it as the representative of the column name by using two level, which is table name dot column name, right? So this is where instead of writing every time the table name, you can create a table name as giving its nickname or alias. So you write as clause, as keyword in your from clause. So give alias name for this table. And this alias name, you can give it in your coding. So it is telling it's the just an abbreviation to your table. So the table alias is a temporary alternative name for your table. You can make the query easier to read by using this alias names on your table by giving a keyword as. So hence you write it as C in your from clause is you're combining with transaction. So table names are separated by comma and transaction alias you're writing T, and in your where clause and select statement you're writing T dot ID is equal to T dot ID. C dot ID is equal to T dot ID. And this is where you get only the matching rows, which is also termed as inner join. So this result is similar like your data set or data step merge technique. See, what are you doing? So open this demo D04. Do we have that demo? If it's not there, it's very simple. So currently just type these two results or these two codes on your slides and check the output. Go ahead. So moving ahead, if you want to see the same result if you are getting with your data step, let's write data. We are creating a new data set. Suppose I write some name. Fine. Merge. What is the merge? We are going to merge with customers. Space, it's a data step based as concept, no comma, no comma to separate the tables, transactions. Correct? Fine. Run.
Yeah.
So before this, we want to select the column rows. So how you select the column rows? In merge, you are going to create two temporary variables in equal to, suppose I write C, and with transaction, I write in equal to T. So these two temporary variables, I'm going to use the concept to select the matching rows. So I write if C equal to T. Correct? Agreed?
Yes, matching.
Right? So now when I execute this data step, so what has happened? Is it selecting matching rows?
Sorting.
But it did not ask anything about sort. So it's giving 3 rows. If C is equal to T, we are not going to use it this way. We are going to write if C equal to 1 and T equal to 1. This is what is requested. Correct? So
Yes.
this is your data step, and we write a proc print so that we get the result in your result window. Data equal to cust underscore trans run.
Cust.
And what cust? So I'll select both the steps together so that I get the result, one of SQL in my output and one is of my data step. Okay. So it should ideally take this.
By variable. Sorry, by statement.
By statement we are missing. But in ID do we, okay, yes.
Should we mention c.id? Not, no, because it's giving still errors.
By variable is not sorted properly. That's why we wanted to have this proc sort. Data equal to customers. Do not, I will not disturb the original data set. So I write customers, leave it by ID. Okay. Proc sort data equal to transactions by ID. Fine. Done. So this is the result of your SQL. This is the result of your proc print. Do you get the same result? Matching rows?
We need to sort separately initially.
Yeah, that is required with base SAS. But the concept is matching rows we have selected with proc SQL Inner Join. Is the result similar to your data step merge technique?
Yes.
Are you getting it? Of course, a single step of proc SQL is giving you the same result as compared to multiple steps of your base SAS. Correct? Are you all with me?
Yes, Ashwin.
Yes.
So this is what it was telling, that SQL inner join versus data step merge. So proc SQL inner joins and data step match merge can return the same result. So when you write this type of statements in your data step merge, you are selecting only matching rows. Correct? So it is matching rows which is similar like inner join of your proc SQL. So it's the slide now where it's telling SQL inner join versus data step merge. So now you have table called as customer 2 and custom transaction 2. Now look at this ID values. Look at your code and look at the output of your SQL output. So do every time your SQL result and data step merge gives you the same result. Look at the result here. Look at your two tables. If you have written data step merge, ideally would it give the same result as they are showing you with SQL output? Look at it carefully. So what is happening? If it would have been a data step merge, what would be the result? And this is the result for SQL Join, which they are showing it here. What is happening? They are highlighting common rows.
Repeating
Look
the
at,
rows.
so look at your SQL result. But if it was a data step, how many rows you would have get with merge?
I think it will take the common ID. It will be common.
Look at your SQL output.
Two rows it should come. Sorry, two observations.
Correct, for your data step merge, correct?
Yes.
With SQL, you are getting 4 rows.
4.
So is your row, like always the inner join of SQL would give you the same result with data step merge?
No.
So what has happened in SQL join? Look at it. Why it's giving you 4 rows?
They're joining it with both of the 102s to 102s. So they are
Correct.
making it 4.
Absolutely. So what has happened because of its initial behavior as Cartesian product, it will first perform a Cartesian product, then it will subset on this rows criteria. That's why you're getting this type of result. Understood difference? Yes.
Yes.
So
Yes.
the default nature is Cartesian product.
Cartesian product.
Correct. That is why you get this type of output. So if you want to see this, let's have your code for customer 2 and transactions. So you have this code 4D00B. So if you open this, you have customer 2 and transaction 2. So let's create these two data sets. So these two data sets have been created now. So let's work into our program. So we write proc SQL, select, I'll write select later on, from customers to, comma, transactions to, where c.id is similar to c dot t dot id. All right. So let's give alias name here also as c. And here you can write c dot id and the rest columns. So they're selecting all. So let it be all. Okay. So if I do not write this, I comment it out here. So this is the natural behavior. Let me check the column names, table names properly. See, now every table from each customer 2. Now customer 2 had 5 rows, transactions 2 had 4 rows. So 5 into 4, 20. Hence the default behavior is a Cartesian product. See,
Yeah.
if you check your log, it will give you the message. See, it's telling it's a Cartesian product. Now, if I go back and restrict the rows which I want to select, before that, understand this. So every row from the first table is combining with every other row from your second table. See, rows from each transaction row from your right side, whereas left side is the every row from the first table, which is 101 ID. Okay, 101 ID. So 5 rows from here, 4 rows from this table. So it's combining. Now I go back to my code and I work with my where clause to select only common rows. Done. So what is it? It is selecting common rows, but because its default behavior is Cartesian product, it first creates a Cartesian product and then on that Cartesian product, it is working on your where criteria to subset the data on common rows. Are you getting the difference now? So that's what it was telling. So you have this activity A02 that we are selecting to select only common rows from both the data sets. So open this activity A03. Do we have it? No. So if we don't have it, I'll simply, of course, I'll have to sort those data sets. Proc sort data equal to customer 2 by ID run. Proc sort transaction 2 by ID run. So you are creating, see, these two temporary variables with in equal to dataset option called as cust ID. Correct?
Yes.
Check it again. I'll re-execute.
There is data missing, Ashwin. Data equal to transaction. Proc sort statement.
Yes, thank you, Monica. So sorting, merging, good. Now let's see the output for both. This is the proc SQL and this is for your merge. See the results. This is your SQL output. This is your data step merge. So not every time your data step match merging result will be same with your inner join of your proc SQL. That's what they wanted to tell you. All fine. Why? Because in data step, you are selecting only matching rows, but when it comes to SQL, though it will perform the baseline as a Cartesian product, it will first create a Cartesian product and on that Cartesian product, it will select the matching rows. Hence, you get the number of rows, which is slightly more in SQL result than compared to data step result. All right, everyone. So you can always try this. I'll give you in your chat box. Work on this. So every time we are not going to get the same result with SQL inner join with your data step merge. Okay. So always remember, and this is a part of your interview question. Fine. Moving ahead, answer this poll. How many rows you find in this data step merge?
2 rows.
Yes.
Yes, true.
Yeah,
The,
2 rows.
the same code, how many rows we had in data step merge?
2 rows.
2 rows.
2 rows, yes.
Absolutely. With SQL, you had 4 rows. It's because the default behavior of SQL is the Cartesian product. Okay. So
Yes.
compare SQL join versus data step merge. Key points: explicit sorting of data before join. Is it required in SQL? No. Data step, yes, it's required. Same name columns in join or merge expression. Again, in SQL, it's not required. In merge, it's required with the same name columns. Equality in join or merging expression is not required. Its equality depends on the number of rows, okay? Or even in the level or the position of rows, but it's required in data step merge. Fine. So this was about SQL inner join. So the alternate syntax for inner join is this, where you write inner join in between the two table names, and you give a separate on clause, which is a joining criteria, and let your where clause work as it is to subset your data with a where expression. So it would be like this. So this is your first syntax with where you are performing the inner join. The second syntax is you write proc SQL, select, let this be as it is. Okay. From, let this be also the same. And here, instead of writing a comma, you get introduced to a clause called as inner join. Okay. On this table, where the joining criteria to write on, telling c.id is same as t.id. That's it. So if you check the output for both this, you'll get the same. See, result is same. Correct? So this is an alternate syntax for your inner join, where you specify inner join, where one table is joining with the second table as inner join on the criteria where their IDs are similar. Okay, so try this code. Done? Yes?
1 minute, Ashwin.
Okay. Take, let me know once you have done.
Done, Ashwin.
Others? Can I have reply, please?
Done. Done, Ashwini.
Done.
If you have understood the syntax, okay. So this is this alternate syntax for SQL inner join. Most of the time use this syntax itself, inner join. Okay. All right. Answer this poll now. How many tables can be combined using the following syntax? Any idea? This is the very first syntax, and I have already discussed
256 you said earlier.
256. Yes. In this syntax, you can have maximum up to 256 tables to be joined. But when you write a syntax with inner join clause, there is a restriction. At a time, you can join only 2 tables. Okay. All right. So this was all about inner join. So as exercise, I leave to you as a self study. Let's move with outer joins. So we'll understand here what is the join of 2 tables on non-matching columns and include non-matching rows from one table. We'll join 2 tables on matching columns and include non-matching rows from both the tables. And of course, we'll compare between your outer joins and data step merges. So as we got introduced with outer joins, so we know there are 3 types of outer joins: left, full, and right. Okay, so left means you are selecting non-matching rows from the left table. Left table means the table which you are writing first. Okay, of course, along with the matching rows is called left join. This is including all matches and non-matches, it's full join. Whereas here, matching and non-matching from the second table or the table which is written on the right side is called as a right join. Fine. So let's understand this scenario. So what is telling in this scenario? You have been asked for a report that displays all customers and any recent transactions that they have completed. You want all customers and their recent transactions. So tell me, what is this type of join?
Left.
Absolutely correct. So how you'll move ahead with this is, earlier we had customers and transaction table. So we are going to write proc SQL. Let's select the same thing. Instead of here, we are going to use the concept left join. All right, on this table where we are going to write c dot id, not where, on c dot id is equal to t dot id. All right. See all the customers from first table and matching from the second table. Whereas this 001 is not been contributed from your second table, hence its action and amount is blank. Now action is a character column, hence the value is blank. Amount is a numeric column, hence it's representing with period. So this is matching and this two are non-matches. Got it? So it is called as a left join. So the table which you are writing first before your left join is termed as your left table, and this is termed as your right table. Now, if I write the same code where I now use, instead of left, the concept as right. Now I want only the customers who had the transactions. Okay, now because this table I have written it at the right table, it will select only all the rows from the right and matchings with customer. So if I move ahead and execute this, This is my right. See, all right side rows and matchings only from the first. Correct? And I write here full join. This I can write a title. Left join. This is my right join. And a third title. Full join. Check the result carefully. Check the result carefully. Look at your left, look at your right, and look at your full join.
Yes, Ashwin.
I have question, Ashwin. Why this ID is not appearing on like 103 and 105 from the transaction table in full join?
Yeah, tell me, Monica.
Yeah, in full join, it should become like both combining both table like transaction and customer, right? Then why two IDs not appearing 103 and 105?
It's because see, I have written the same thing, no? C.id.
Oh, that's why it's just
That's
appearing
correct.
customers. Okay.
Correct. But I did
Okay.
not use star. In case for your question, a very good question, I just simply write it this way. Okay, it's a full join. Let's check. Got it now?
It's still not appearing, right?
It's coming, right?
Oh, okay. Yeah.
ID name from first
Uh-huh.
table, ID
Yeah.
action amount from the second table. But this is
Okay.
a full join. So
Yeah,
full
it's
join is
created.
giving you, right. So full join is giving you non-matches as well as matches
Oh,
from both the tables.
yeah, it's created one more table, right? In bit like ID. Yeah, I got it.
Understood?
Yes, yes.
Okay. Others
Yes, Ashwin.
Yes, Ashwin.
understood how is doing left, right, and full. Okay. So if this is fine, so this is what we had seen. So report 2, it's telling outer join. You have been asked for a report that displays all customers and any recent transactions that I have completed. So this is the left join. So you get this output. Outer joins, one of it left join syntax. So your syntax is in your from clause between the two tables, you write left, right, or full join. Of course, on the joining criteria is required. So you get your result is left join. Now determine which table is left or right. So the table which you write before your join clause is called as a left table, and the table which you write after your join clause it's called as a right table. So this could be your first, this could be your second, but we term it as right table and left table. All fine, everyone? So how is this left join is working here? So it's include all rows from the left table, even if there are no matching rows in your right table. So it's selecting matching as well as non-matches from the first table. Now right table or right join is exactly opposite. It will select all the rows from the right table or the second table and non-matches from the first table. Includes all rows from the right table even if there are no matching rows in your left table. See, all transaction rows. Now I have a question. The result currently for my left join is like this, where I am selecting all the rows from customer table. What I do is I change the table positions.
You will see the right join result, right?
The result is still the left join or right join. It's a left join. The result will appear as a right join result, but it's because my transaction, I have written it as the first position and customer at the second position. I'm telling left join. So transaction is my table, which is action amount.
So the result
So what
of
has
the
happened?
titles, the result of the titles left join and right join are same now.
No, for this currently tell me what has happened. Left join.
All rows from transactions table we got.
So what I do here now is T dot.
T,
But
yeah.
it's left. Left means first table.
But it will take transactions as the first table because we gave it first, right?
Hmm.
So it will just capture the information from the transactions, like same Nilima said, the full everything from transactions.
Absolutely.
Yeah.
Absolutely. Okay. So it depends on your table situation or where the position of your tables you're writing in your from clause. Accordingly, you can describe the joints. Okay. So it's like something which I just wanted to think on. Okay. So that's all it is. So as per your scenario, you want here all the customers who have performed the transactions. So you use the right join option here. See? Okay. Yes, so full join is matchings as well as non-matches both. So includes all rows from both tables, even if there are no matching rows in your entire table. So there is a quiz. Given this to select statement, look at the select statement carefully, look at its syntax. It's left join, right join. It's the same thing which we have discussed currently, okay? Will the result set contain the same data? Understand the keyword is data. What is the difference in the results?
Data will be the same.
Hmm.
The columns are in different order, right?
Absolutely. Absolutely. It's the same thing. Okay, what I had done was the same thing. Let this be as it is. Okay. What I'm doing is I select all the columns. All right.
Alias
Is okay. See now, this is all coming from your left join result. See, ID action amount is from your transaction table, ID name from customer table. Because I have used left join, So first table is transaction. So all the columns and rows from your first table, which is transaction, and customer is the right table. Understood?
Yes.
Yes, sir.
Yeah. So the question here is, will the result set will be the same, and what is the difference in the result? So result is the same. Okay, only the difference is columns would be in a different position. Correct? Because here it is left join to customers, here it is right join to customers. So all the rows from customers will be selected in both the table. Only difference is because it's on the right side here, you'll get all the rows from customer from right side. And because customer is on the left side, it will come from the left. Getting it? This is how it's telling. See columns. See columns. Column positions are changed. Data is same. Yes. The columns are in different order. Understood?
Yes.
Yes.
All right. Now the third result is management is considering a matching spouse donation program. A report is needed showing employees who are married and make contributions to company sponsored charities. So you have two tables, donations and employee payroll. So donations will give you the information for all the employees who are donating, whereas employee payroll is the general table for all your employees, irrespective whether they are donating or not donating. Agreed? Yes,
Yes.
agreed. So it's telling management is considering a matching spouse donation program. A report is needed showing employees who are married and make contribution to company sponsored charities. So this is your main table for payroll, and this is actually it is a subset donations of payroll where you have information for customers who are donating. But when we have donation customers, remember we have all the customers, either they are married, single, divorced, okay? But we want only those which are married. So donation is a part of employee payroll. Always remember. But we want only those people who are contributing for donations, but they're married and they're also part of payroll. Of course, it's a right join. So how it works here? Oh, sorry, left join. So this is what it's telling. Understanding your business. As a whole, you have an employee payroll. Of course, from this, you have a donation, which is a part of it. Among donations, you have the people information who are married, who are unmarried, who are divorced, and all those, okay, who are performing charities. So you have part people who are married. Of course, married is a part which are also from your payroll, but those may not be contributing. But we want only this who are married and contributing for donations, which are the part of your payroll also and a part of your donations also. So of course, it's going to be a right join. Understood, everyone?
Yes, sir.
Yes,
Yes.
everyone. Swarupa,
Yes,
Padma, Nilima, Priyanka.
yes, Ashwini.
All right. So married employees get all this. Employees who donate to charities include donation data will matched. Whereas this is an employee payroll. These are employee donations who donate to charity. So answer this poll. For the report, you need the data for all married employees from Orion.employee payroll. You also want to include the charity names from the Orion.employee donations table. If employee ID matches, what type of join should you use to combine the information from these two tables? Left, right, full, inner, none of the above.
Full join.
Since
Because
How?
all married employees from first table, left join.
Look at this diagram.
right join.
we need all the information.
So which table will be your right table?
Employee.
Employee payroll will be your left table. You need information from that completely, right?
So
Don't
in this option, they have given inner, left, full, none of the above.
Left join.
There need to be
Right.
Pay,
So
payroll.
you write your donations as your first table, and then you write your payroll as second table, then it will be a left join. Got it now?
Yeah. Yes.
So this is what they would tell. Employee donations, left join with payroll, where you write ID is common, and of course only those people whose marital status is M. And you are selecting D.employee ID recipient as per the scenario. So output order is not guaranteed unless an order by clause is included. Okay, so that is a different thing. But left join when you write donations. If I write donations here and payroll up, then it would have been right join. All right. Yes.
Yes, Ashwin. Yeah, on this.
So this is where you get all employees who are donating and of course who are married. So data step merge, of course the prerequisite you need to sort your data. So it's telling data step with merge and your by statement combines tables similar to an SQL join. Columns are treated differently in the result. Always remember. Now look at here. You have ID name, ID, action, amount. So this is your customer and transaction. So we know this data is sorted on the basis of ID. And it's a prerequisite for data step merge. So when you write a data step and you're merging, you're not selecting any common rows. So it will simply join the rows where it will select matches and non-matches. But look at the columns. So by default, the column is taken only once. This is your data step merge technique with common columns. It gets overlaid. So data step merge automatically overlays same named columns. Agreed?
Yes.
Okay. So this was your earlier left join with your donations and okay. So now here, this was your donation and employee. So we are performing left join. So look at the columns which you have selected D.employee ID and recipient. Okay. So you get this. So in case I copy this code and I use asterisk. Now here we have huge tables. So this will be something which is inappropriate. But here, see, when I used asterisk for customer and transaction, you were getting IDs, same columns, correct? But did it overlay common column here as your data step merge?
No.
No, correct? So that's what it is telling here. With data step by default, your common columns gets overlaid. But what if we want to do the same thing with your SQL? That you don't want to select c.id in your select clause and you want to select all the columns from all other tables like this. But we want the result where this ID should be same. So what we can do is we use a function called as coalesce. Okay. So this is where we tell c.id is same with t.id. And then you can select all other columns. Okay, so that is also one thing which you do with coalesce function. See, and you gave it as ID, name, action, amount. So you can use coalesce function to overlay columns. The coalesce function returns the value of the first non-missing argument. So you get this result similar as your data step ID. So instead of selecting which column to be taken in your select clause, you write coalesce function, give a common name, common column name, and select other rest of the columns. So this is one of your interview question also. Explain about Colliers function. People will ask you about what is a Colliers function. Or they may give you a scenario and they will tell you how you will have a common column. So in that case, you can make use of this function called as Colliers. All right. So comparing inner joins and outer joins. So key points in inner joins and outer joins, table limit are 256. Join behavior in inner is returns only matching rows, whereas outer returns matches and non-matches. Join options, matching rows only. Here you have left, full, right. Syntax, yes, we know there are two syntax in inner join. We have only one syntax on clause that specifies join criteria. Any questions here? Yes,
No.
and an exercise. So let's come to one of the exercise here. So let's do this exercise. Level 1, page 4-32. Exercise number 4, it's telling it's an outer join. So you can read this and get the result as per this requirement. Go ahead and do this exercise, please. Page 4-32, level 1, exercise number 4, which is outer join.
Yes. This meeting.
So if you have done with this, it's all good. Next topic which we'll be looking is complex joins, but I won't take it today because as the word is complex, it's not complex at all, but it may feel as complex for you. So let's take this as fresh in our next class. All right. So for this, we'll stop our day. Thanks for attending the class. Good night. Take care.